You're falling toward a black hole. In 3 seconds, your body will stretch like taffy. In 10, you'll experience 1 billion years in an instant. And at the very center, reality itself breaks. This isn't science fiction. It's what physics says actually happens. And what you're about to discover will change how you see the universe forever. Black holes aren't just cosmic vacuum cleaners. They're not holes at all. They're the universe's most extreme objects, places where gravity is so intense that it bends space, stops time, and tears apart the very laws of physics we thought were unbreakable. For decades, scientists wondered, what actually happens if you fall in? Do you die instantly? Do you see the end of time? Or does something far stranger occur? The James Webb Space Telescope recently observed matter spiraling into a supermassive black hole 13 billion light-years away, and the data revealed something no one expected. But to understand what they found, we need to take you on a journey, from the event horizon to the singularity, and show you exactly what happens at each stage. Prepare yourself, because once you cross that boundary, there's no coming back. Let's start your journey 1,000 kilometers from the event horizon of a stellar mass black hole, one about 10 times the mass of our Sun. From here it looks wrong, not like a black sphere, more like a distortion in reality itself. The stars behind it appear warped, bent around its edges in a perfect circle of light called the photon ring. Light itself is trapped in orbit, creating a glowing halo around absolute darkness. As you fall closer, something strange begins to happen. Time. Your watch still ticks normally from your perspective. But to anyone watching from a safe distance, your crewmates on a distant ship, you're moving in slow motion. At 100 kilometers out, they see you taking minutes to move meters. At 10 kilometers, hours pass for them, while seconds pass for you. This is gravitational time dilation, and it's not theoretical. It's measured, proven, real. GPS satellites have to account for it, or your navigation would fail. But here, at the edge of a black hole, it becomes extreme. Now you're 100 meters from the event horizon. Your crewmates see you frozen in time, your image red-shifted, dimming, stretching. To them, you never actually cross the boundary. You appear to hover there forever, your light fading until you vanish from view. But here's the twist. From your perspective, nothing special happens. You don't slow down. You don't feel anything unusual. In fact, you cross the event horizon in less than a second. One moment you're outside, the next moment you're inside. And the universe has fundamentally changed. You're across. You've passed the point of no return. What does it look like? Behind you, the universe appears compressed into a brilliant disk of light. Every star, every galaxy, all of cosmic history squeezed into a shrinking circle. The light is blue-shifted, its entire electromagnetic spectrum accelerated by gravity into high-energy radiation that would, in reality, kill you instantly. But let's assume you're somehow protected, because what happens next is even stranger. Ahead of you, where the singularity waits, is perfect blackness. Not the blackness of space, but the blackness of nothing. No light can reach you from that direction, because every photon, every particle, every piece of information is being pulled in the same direction you are. Down, always down, toward the center. Here's the thing most people get wrong. Inside a black hole, the singularity isn't a place in space. It's a moment in time. A moment in your future that you cannot avoid, no matter what you do. Try to fire your rockets away from it, doesn't matter. turn around and accelerate at full power, doesn't matter. Even if you could somehow travel faster than light, which you can't, you still couldn't escape. Because away from the singularity is a direction in space, and inside the event horizon, all directions in space point toward the future. And your future is the singularity. It's like trying to avoid next Tuesday. You can't. Tuesday is coming whether you like it or not. But here's where it gets truly strange. As you fall deeper, you start to feel something. Not gravity exactly. Something worse. Tidal forces. Your feet are slightly closer to the singularity than your head. Just a meter or two of difference. But in the extreme curvature of space-time inside a black hole, that tiny distance means your feet experience vastly more gravitational pull than your head. You start to stretch. Scientists call this spaghettification, and the name doesn't do it justice. This isn't gentle stretching. At first, it's like being on a medieval rack. Then, like your body is in a hydraulic press and a taffy puller at the same time. Every cell, every molecule, every atom in your body elongates as the difference in gravitational force tears you apart along your length. But here's what's truly horrifying. You'd be conscious for some of this. Your brain would still function for a few seconds, maybe longer, as your body deforms beyond recognition. You'd watch your hands stretch into grotesque tendrils. You'd feel your bones crack and separate. You'd experience your own body becoming one-dimensional. And then, at some point measured in fractions of a second, you'd reach the molecular limit, the atomic limit. Your very atoms would be ripped apart into subatomic particles, and those particles would continue falling, now separate streams of quarks and electrons, spiraling down toward the singularity. Here's where things get genuinely strange, where the James Webb discovery comes in. Stephen Hawking proved that black holes aren't entirely black. They emit radiation. Hawking radiation. Over unimaginable timescales, trillions upon trillions of years, a black hole will evaporate completely, particle by particle, until nothing remains. But here's the problem. Hawking radiation is random. It contains no information about what fell into the black hole, which means all the information that ever crossed the horizon, every atom, every memory, every quantum state, is destroyed, erased from the universe. This violates a fundamental principle of quantum mechanics. Information cannot be destroyed, ever. It can be scrambled, transformed, hidden, but not destroyed. This is the black hole information paradox, and it's been tormenting physicists for 50 years. Recent observations from JWST of matter falling into distant supermassive black holes have revealed something unexpected. The X-ray signatures don't quite match what classical physics predicts. There's a quantum signature in the radiation just before matter crosses the horizon, something that suggests information might be escaping after all, encoded in subtle correlations in the Hawking radiation itself. If this holds up, it means the interior of a black hole might not be separate from the exterior at all. They might be quantum entangled. What happens inside is reflected outside in ways we're only beginning to understand. And that leads to the most mind-bending possibility of all. When you fell into the black hole, you didn't just experience your own personal journey toward destruction. You became entangled with the black hole's quantum state. A version of you exists in the Hawking radiation that will eventually leak out over trillions of years. Your information will be preserved, scrambled beyond recognition, encoded in particles that won't be emitted until long after every star in the universe has died. In a sense, you survive. Just not in any way that's meaningful to you as a conscious being. So what actually happens inside a black hole? The honest answer is, we don't fully know, and we might never know. The event horizon is an information barrier, a cosmic censorship that hides the interior from any possible observation. But what we do know is extraordinary. Time and space switch roles. The singularity is in your future, not your location. Tidal forces tear you apart, atom by atom. And somewhere, somehow, your information might be preserved in the quantum fabric of the universe itself. Black holes are the universe's way of saying, here's the limit of what you can know. They're cosmic horizons beyond which physics becomes speculation, philosophy, mystery. But here's the beautiful part. We're getting closer. With Webb, with gravitational wave detectors, with advances in quantum gravity theories, we're beginning to probe these mysteries in ways that would have seemed impossible just decades ago. The universe has black holes for a reason. They're not just destroyers, they're teachers. They show us where our understanding breaks down, where we need new physics, where the next revolution in human knowledge lies waiting. If this journey into the most extreme places in the universe left you with more questions than answers, good. That means you're thinking like a scientist. That means you're ready to join us as we push deeper into the unknown. Hit subscribe if you want to explore more of these reality-breaking topics. Drop a comment telling me, would you ever risk falling into a black hole if you could somehow survive? What do you think actually exists at the singularity? And remember, somewhere out there, 13 billion light-years away, matter is falling into a black hole right now. Atoms that were once part of stars, planets, maybe even life, crossing the point of no return and experiencing everything we just described. The universe is more strange, more beautiful, and more terrifying than we ever imagined. You're still here. That means you made it back from the event horizon. Congratulations. Not many do. But here's something to think about as you go about your day. Every black hole was once a star. A massive, brilliant star that fused elements, created light, and warmed planets. And when it died, it collapsed into darkness so complete that not even light can escape. One day, trillions of years from now, even the black holes will evaporate. The universe will be cold, dark, and empty. Nothing but radiation spreading thinner and thinner across infinite space. But for now, we're here. In the brief cosmic moment when stars shine, when planets form, when life can look up at the sky and ask, what's out there? What happens at the edge of the unknown? And sometimes, if we're brave enough, we find answers. Thanks for watching. See you in the next one.